Study of heat transfer. Note down. Study of heat transfer from one body to another. From one body to another body. Study of heat transfer from one body to another body. Okay. So heat is something which can be transferred from one body to another. Like for example, water. Suppose this is a water tank. Water tank. You connect the water tank with a pipe. You want to water the plants. Okay. So water will flow from high level to low level or low level to high level. Water. High to low. Correct. So water flows from high level to low level. Similarly, electric current flows high potential to low potential, high potential to low potential. So similarly, we have heat also. Heat also it is transferred from one body to another such that it is transferred from high temperature to low temperature, high temperature to low temperature. Okay, low temperature. Correct. Sometimes temperature is same, but still heat transfer. See, like high temperature, low temperature, heat will transfer. What do you call that type of heat? Specific heat. Specific heat. And suppose temperature is same. If temperature same, if temperature same, phase changes. Phase. Solid to liquid, liquid to gas. Then what you call? Latent heat. That heat is known as latent heat. Latent heat means hidden. Latent heat is hidden. Why it is hidden? Hidden means you see the temperature is same, but still heat is transferred. Correct or not? That's why we call it hidden. Okay, it's a the meaning of latent is hidden. So what is the value for ice to water? Ice to water latent heat. What is the value? 80 calorie per gram. 80 calorie per gram. And similarly, water to ice. Sorry, water to steam. Water to steam 540. Okay, 540 calorie per gram. Suppose 1 gram water convert into 1 gram steam at 100 degrees Celsius, both at 100 degrees Celsius. So 540 calorie is absorbed. If you give 540 calorie to water at 100 degrees Celsius, it will convert into steam at 100 degrees Celsius. If you give 80 calorie to 1 gram ice at 0 degrees Celsius, it will convert into water at 0 degree Celsius. Okay, understood? The solid will convert into liquid. Understood? And here liquid will convert into gas. Right or not? Steam. Steam is gas. Okay, fine. So, and similarly, we have specific heat. Specific heat. What is the symbol for it? S. So, suppose 1 gram water at 0 degree Celsius. Okay, you are converting it to 1 degree Celsius 1 gram water. So it will accept how much calorie? 1 calorie. It will absorb. It will gain. It will gain or absorb 1 calorie. From 1 degree Celsius to 0 degree Celsius, it will lose. It will lose heat. Okay. Similarly, minus 1 degree Celsius to 0 degree Celsius, ice, 1 gram. How much heat it will absorb? 0.5 calorie. 1 gram ice at minus 1 degree Celsius is heated so that the new temperature is 0 degree Celsius, how much heat it is absorbing? 0.5 calorie. Correct? Understood? So what is the specific heat of ice? 0.5 calorie for 1 gram for 1 degree Celsius rise in temperature. Specific heat of water 1 calorie per gram per degree Celsius. Steam also same. Specific heat of steam is 0.5 calorie per gram per degree Celsius. Okay, clear? So, we will do some questions now. So note down. Mixing questions we will do. Suppose 10 gram water at 10 degrees Celsius is mixed with 10 gram ice at 0 degree Celsius. Find final temperature. So which has more heat? Which has more heat? Water has more heat because temperature is high and water is liquid. Liquid has more heat than solid. Gas has more heat than liquid. So water is liquid, ice is solid. So what are the possibilities? You see what are the possibilities? Final temperature 0 or final temperature between 10 and 0. Is it possible final temperature less than 0? Less than 0 not possible. Final temperature less than 0 not possible. Tell me why. Why final temperature less than 0 not possible? Tell me why. What is initial temperature of ice? 0. Suppose final temperature is less than 0, maybe -1. It means ice is losing heat or gaining heat. Tell me. Losing heat. And water is going from 10 degrees Celsius to -1 degree Celsius. So water is also losing heat. But so that is not possible. One should lose heat, other should gain heat. Are you getting? So final temperature less than 0 not possible because, no doubt, both ice and water will lose heat. Both ice and water cannot lose heat. Cannot lose heat. If one is losing heat, other is gaining heat. Okay. Okay. You tell me why final temperature more than 10 not possible. Final temperature more than 10 degrees Celsius not possible. Tell me why. Say suppose 11 degrees Celsius. Why not possible? What is initial temperature of water? 10. Initial temperature of ice? 0. If final temperature is 11, it means both are gaining heat. So both cannot gain heat. Both cannot gain heat. Okay, no doubt. Both cannot gain heat. So one should lose, other should gain. Okay, like this. One object gain heat. Gain heat means absorb heat or takes heat. Other should lose or release or give heat. Okay, lose, release, give. So now you come to T final 0 possible. How it is possible? Tell me. Because if T final 0, water is losing heat. It is going from 10 to 0. And how ice will gain heat? By melting. Okay. Water lose plus 10 degrees Celsius. 10 degrees Celsius to 0 degrees Celsius. It is losing heat. Ice gain heat by melting. If ice is melting, it is gaining heat. So solve this. Solve. You assume m gram ice melt. Let m gram ice melt. So what is the heat gained by ice? Tell me. Heat gained by ice. Tell me. Tell me. Heat gained by ice. What is the formula for latent heat? Q is equal to ml. Tell me. So m into AT. And what is the heat lost by water? Heat lost by water. Tell me. Ms delta T. So m. So mass is given. For water, what is the mass? 10 gram. Specific heat of water 1. And what is the delta T? Magnitude 10. Very good. 10 minus 0. Magnitude. Okay. Magnitude. Greater minus smaller. Now equate both. So 80 m is equal to 10 into 10. 10 10 cancel. So what is m? 10 by 8. 10 by 8 how much? 5 by 4. 5 by 4 1.25. 1.25. Note down. So how much ice was there initially? 10 gram. Out of 10 gram, 1.25 gram ice melting possible. Out of 10 gram, 1.25 gram ice melting possible. Okay, note down. It is possible. So what is the answer? Tell me then. Final temperature 0. Final 0. Note down. So final temperature is 0. And finally, how much ice there? How much ice finally in equilibrium? Initially 10 gram. Initial ice is 10 gram. Now how much melted? 1.25. So what is the final ice? 10 minus 1.25. Okay. And how much finally water? Correct. So initially 10 gram. Now 1.25 coming. Okay. So note down. So this is the amount of ice and water in final mixture. Okay. Final mixture. So final temperature is 0 degrees Celsius. Okay. Right now. So think like this. One is gaining heat, other is losing heat. One is gaining heat, other is losing heat. Note down. So finally this much ice and this much water. Okay, clear? Practice. Okay, do more practice and think also. You have to think. There is no shortcut formula. Okay, shortcut formula sometimes you will struck. Okay, so thinking is very important. See what is going on. Now you tell what change I do so that final temperature is more than 0. What change I do in the question? Which amount I increase or decrease? If you increase water amount, correct, very good. If you increase water amount and solve the same question, then your answer will be this. So let's take this is 100 gram. Okay, solve using 100 gram. 100 gram water. You start solving. Next question. Now change here 100 gram. 100 gram water at 10 degrees Celsius mixed with 10 gram ice at 0 degrees Celsius. 100 gram water at 10 degrees Celsius mixed with 10 gram ice at 0 degrees Celsius. So suppose you assume let T final 0. Let's check. So what is the heat loss? Tell me. Lost by water, tell me. 100, 1. What is delta T? Final 0. For water, what is delta T? 10 minus 0. So how much heat lost by water? 1000 calorie. And gain by ice. What is heat gained by ice? Let m gram melt. Let m gram melt. So because initial temperature of ice 0, all 10 gram ice solid 0 degree Celsius, whole every all 10 gram ice, what is the state? Solid. Now, but still it is gaining heat. Solid ice gain heat means what will happen? It will melt. Okay. So we don't know how much melt. So we assume m gram. So what is the heat gain? ml. Now equate. So m into 80 is equal to 1000. Heat lost is equal to heat gain. So what is m? 100 by 8. So it is more than 10 or less than 10? More than 10. So not possible. But only 10 gram ice was there. Only 10 gram ice was present initially. Only 10 gram ice was present initially. So this is not possible. So not possible. So what is the next possibility? T final less than 0, less than 10, greater than 0. So now you see this is 10 degrees Celsius, this is 0 degrees Celsius, and this is final. So water is coming from 10 to T final. Ice is coming from 0 to T final. So what is the heat lost by water? Tell me, lost magnitude. Magnitude to tell. What is the ms delta T? Ms delta T. M mass of water 100 S delta T magnitude. Magnitude of delta T. Tell me magnitude. TF minus 10 or 10 minus TF? Magnitude. Which is greater? TF or 10? 10. So 100 into 10 minus TF. 100 into 10 minus TF. And what is the heat gained by ice? Now what is, now final temperature is more than 0. So whole ice will melt. Whole ice melt. So and so what is the formula for melting, ice melting? What is the formula? ml, melting ml. Now whole ice will go from 0 to TF. So ms delta T. Now after melting, ice is not solid, it is liquid. So what is the specific heat? Are you getting? After melting, solid or liquid? Ice is solid or liquid? Liquid water. So specific heat of water you have to write. Don't write 0.5 here. 1. Because ice melted. Now what is delta T? TF minus 0. TF minus 0. Okay. So you solve this. So 800 plus 10 TF. Okay, clear? Now equate these. So heat loss is equal to heat gain. Note down. Heat loss is equal to heat gain. Solve. So 100 into 10 minus TF is equal to 800 plus 10 TF. Okay, 10 cancel. So 10 into 10, 100. 100 minus 10 TF is equal to 80 plus TF. Take minus 10 TF right side. So 20, 11, 80 left side. Okay, carefully, slowly you solve. So 20 is equal to 11 TF. So TF is equal to 20 by 11. 20 by 11 means 1, 1.8, correct? 1.8, again 1.8, 1.818181 like this. It's degree Celsius, not down. 1.81 degree Celsius, not down. 1.81. Okay, clear? You have to think also. See, short tricks, maybe some books short tricks are there, but don't memorize short. You have to understand. Okay, think what is going on. Understand what is going on with ice and water. Understand what is going on with ice and water, or water and steam. Water and steam. So, shall we do one more question? Okay, let's revise this question. You can see water is more. Water is more. So, temperature will be close to 10. If ice is more, so temperature will be 0 or close to 0. You can think like this. Okay. But after calculation, you check. First, you see the possibility, calculate, then you check. Is it possible or not? Okay. Okay, solve one question for a steam now. Not down. One question for a steam. 100-gram water at 90 degrees Celsius is mixed with 10-gram steam at 100 degrees Celsius. 100 degrees Celsius. See, what is the minimum temperature of steam? 100. What is the maximum temperature of ice? 0. Correct. Good. Find final temperature. Possibility. Tell me possibility. Final temperature equal to 100. Second possibility. Final temperature less than 100. More than 90. Okay. So first you check this. What is initial temperature of water? 90. What is final temperature? 100. So water will gain heat. So what is the gain by water? Heat gain by water. It is going from 90 to 100. So ms delta T, 100 into 1 into 100 minus 90. So 100 into 10. Yes. Assume, let. No, 90 degree not possible. See, final temperature 90 degree not possible. Why? If final temperature is 90 degree, it means steam is losing heat, but water is not gaining heat. Steam lose heat, but water not gaining heat. Understood? Steam lose heat, water should gain heat. What is initial temperature of water? 90. Final temperature 90. So water not gain heat. So not possible. One should gain, other should lose. Okay. Okay. Final temperature less than 90 possible or not? Tell me. Possible or not? Not possible. Why? Both are losing heat. Correct or not? Both water and steam lose heat. Not possible. Are you getting? Final temperature more than 100 possible? Not possible. Why? Both gain heat? Not possible. Both water and steam gaining heat. So not possible. One should gain, other should lose, because only two substances are there. You have seen coffee machine. If you go to any big gathering, many people are there. So coffee machine is there. Milk and water mixture is there. Milk and water, and they pass steam into it. Steam. Okay. So when steam is added to water, water will gain heat, steam will lose heat. Okay, come to question. Okay, tell me. So if final temperature is 100, final temperature is 100. So what is the heat gained by water? 1000. And let m gram let m gram steam condense. Let m gram steam condense. What is the heat lost by steam? M into 540. M into 540. Now calculate, equate it, equate these. Heat gained by water is equal to heat lost by steam. So 1000 is equal to 540 M. Now calculate M. M is equal to 100 by 54. So this is 50 by 27. So you just tell me it is more than 1. Huh? So cancel by 9 3 times. 5.55 cancel by 3 1 25 8 15 5. So how much steam condense? 1.85 gram steam condense. Okay, condense means gas, steam gas convert into liquid, that is condensed. So how much steam condense? Convert gas to liquid. Convert gas to liquid. So how much steam condense? 1.85. How much steam initially? Initially 10 gram. So out of 10 gram, it is possible. Initially steam is 10 gram. So it is possible. 1.85 is less than 10. Okay. Now you tell what change I do, what should I change here so that final temperature is between 90 and 100. Tell me. Whose amount I increase? Water or steam? If you increase steam amount, again you will get same answer, because you will get 1.85, and initially more steam was there. More steam was there initially, 20 gram, 30 gram steam. So out of 30 gram, out of 20 gram, 1.85 condensing, it is possible. But I want final temperature between 90 and 100. Means close to water. So whose amount you increase? Water amount. Okay, let's take 1000 gram. Solve. Take 1000 gram. 1000 gram water at 90 degrees Celsius is mixed with 10 gram ice. Sorry, 10 gram steam. 10 gram steam at 100 degrees Celsius. Okay, now you solve. Try. 1000 gram. So what is the first possibility? First possibility. First possibility. TF equal to 100. I am checking. Check. If final temperature 100, so what is the heat gain by water? Heat gain by water, tell me. Heat gain by water, tell me. MS delta T is 1000 into 1 into delta T, 100 minus 90. So 1000 into 10. So 10,000. 10,000, okay. Calorie. And let m gram steam condense. Let m gram steam condense. So what is the heat lost by steam? Heat lost by steam. Tell me. M into 540. Now equate these. M into 540 is 10,000. So M is 1000 by 54. Now 18.5 gram. Okay, good. 18.5 gram. And how much steam is initially? Only 10 gram. So not possible. But initially only 10 gram steam there. Initially only 10 gram steam there. So not possible. Not possible. Okay. See, the heat gained by water is 10,000. It will gain this much heat when 18.5 gram steam condense. But this much steam not available. Only 10 gram steam available. Correct? So when 10 gram steam available, so it will give less heat. It will give less heat. So when water get less heat, it will not reach 100. It will reach 95, 94 maybe. Okay. So what is the next possibility? Final temperature between 90 and TF. So this is 90, this is TF, this is 100. So water is going from 90 to TF. Steam is going from 100 to TF. Okay. So now you tell. So tell me, what is the heat lost by steam? First, all the steam will melt. How much steam? 10 gram. So it will melt. So when all the 10 gram melting, how much heat lost? 10 into 540. Now the steam is going from 100 to TF. So ms delta t 10 into, now steam condense, now it is water. After condensation, steam is now water. So specific heat 1 and delta t tf minus 100, 100 minus tf, 100 minus tf, 100 minus tf. Okay, this is the heat lost by steam. So what is the heat gained by water? ms delta t. So 1000 into 1 into delta t, tf minus 90. Okay, clear? So now solve this. 5400 plus 1000 minus 10 tf is equal to 1000 tf minus 90,000. Cancel by 10. 540 plus 100 plus 9000 is equal to 100 tf plus tf. So 101 tf, and this is 9640. Okay, 9640. So what is tf? 9640 divided by 101. 101 you take approximately 100. So approximately what is the answer? Tell me. 9640 by 100 approximately is how much? 96.4 degree Celsius. 96.4 degrees Celsius. Okay, clear? Are you getting? So how many understood? Any understanding? Okay. How many? How many? Raise your hand like this. Okay. Okay, good. So see, practice, think. Okay. See, these type of questions immediately you will understand it is good. But practice it. Okay. Practice again and again. Now we'll solve some question. Give me book. So yesterday I gave page number, question number. We'll do some questions. So you keep practicing. Don't think it is, I'm not understanding, I will not cover this topic. Okay, don't do like this. All topics are important. Okay, maybe today you are not understanding, tomorrow you try, Sunday, fresh mind. Okay, try, you will understand it. Okay, it is not something very difficult, you will understand. So so we are focusing on ice, water first. So okay, let's start with easy question first. So there is a question, note down. So page number 646, question 15. Page 646, question 15, solve. What is the question? 10 gram water, 10 gram water at 70 degrees Celsius is mixed with 5 gram water at 30 degrees Celsius. 5 gram water at 30 degrees Celsius. What is the final temperature of mixture? How will you solve this? Now this is easy question. Why easy question? Tell me. Why easy? Water, water. Right or not? Both water. No ice, no steam. So 10 gram water at 70 degrees Celsius is mixed with 5 gram water 30 degrees Celsius. So final temperature will be between 30 and 70. So this 5 gram water will gain heat, 10 gram water will lose heat. Correct or not? Suppose this is water 1 and this is water 2. So heat gain by water 1 is equal to heat lost by water 2. Okay, solve. So how much heat gained by water 1? Tell me. How much heat gained by water 1? 5 ms delta T. 5 into 1 into Tf minus 30. How much heat lost by water 2? Tell me. Very good. 10 into 1 into greater minus smaller. 70 minus Tf. Okay. Magnitude. Greater minus smaller. So 5 Tf minus 150 is equal to 700 minus Tf. So 850 is equal to 15 Tf. So what is Tf? 850 by 15. Tell me final answer how much? Solve. Cancel by 5. 1, 7, 0 by 3. So 5, 6, 56.66. Okay, 56.66 degrees Celsius. Note down. 56.66 degrees Celsius. Now solve 7th question, page 647. Page 647. Question 7. 100 gram water at 0 degree is mixed with 100 gram water at 100. 100 gram water at 0 is mixed with 100 gram water at 100 degrees Celsius. So this is also easy question. Why easy question? Both are water. No ice, steam. So this is water 1, this is water 2. Who will lose heat? Water 2 will lose heat. Water 1 will gain heat. So heat gained by water 1 is equal to heat lost by water 2. So final temperature Tf. Final temperature Tf between 0 and 100. So what is the heat gained by water 1? Ms delta T. What is delta T for water 1? Tf minus 0. Very good. And what is the heat lost by water 2? 100 into 1 into 100 minus Tf. 100 minus Tf. So, okay, clear? 100 cancel. So, what is the answer? Tf is equal to 100 minus Tf. So, 2 Tf is equal to 100. So, what is Tf? 50. Okay. Final temperature is 50 degrees Celsius. Okay, clear? Final temperature is 50 degrees Celsius. Now, I will change this question. I will change. I'm taking this as 200 gram. Now you solve. 100 gram water at 0 degrees Celsius mixed with 200 gram water 100 degrees Celsius. Now you answer. So what do you think? Final temperature more than 50, less than 50? Which has more heat content? 200 gram water at 100 degrees Celsius or 100 gram water at 100 degrees Celsius? 200 gram water at 100 degrees Celsius. More amount means more heat. So let final temperature be Tf. Okay. So final temperature Tf. Any answer? Heat gain is equal to heat lost. So what is the heat gain by 100 gram water? 100 into 1 into Tf minus 0. What is the heat lost by 200 gram water? Heat lost 200 into 1 into 100 minus Tf. So now you cancel 100 cancel. So Tf is equal to 200 minus 2Tf. So 3Tf. 3Tf is equal to 200. So what is Tf? 66.6 degrees Celsius. Okay. So more than 50. Are you getting or not? More than 50. When both are equal amount, 100, 0, 100, 0 Celsius, 100 Celsius, 100 gram. What is the final temperature? 50. Now 100 degrees Celsius amount increase 200. So final temperature more than 50. Okay, more than 50. Are you getting or not? Now suppose I increase this amount. I increase 200 gram water 0 degrees Celsius is mixed with 100 gram water at 100 degrees Celsius. Now you tell final temperature more than 50, less than 50, less than 50. Very good. So heat gain is equal to heat lost. Gain means ms delta T 201 Tf minus 0. Heat lost will be ms delta T 100 into 1 into 100 minus Tf. Solve this. So 2Tf is equal to 100 minus Tf. 3Tf is equal to 100. So Tf is equal to 33.33. Okay, 33. So final temperature 33 degrees Celsius. Okay, clear. So we'll continue. Okay, calorimetry will continue.